All right, good morning, everybody. Hope you're all doing well. Just a reminder, I generally record these and then have to dub over them. All right, so if I mess up, then that's why. One-shot deal. All right, so here are three equations we've been working on, and they come together to give us Ohm's law. We've talked about each one of them a little bit, and here I'm just going to be trying to move us forward. So Ohm's law is R equals V over I. I always write it as V equals IR, even though that's not how it appears in your reference table. Okay, like we said before, it's very similar to F equals ma. F equals ma was very important for us and had lots of different applications, from inclined planes to stuff at angles. V equals IR is going to have the same deal. It's a very simple equation that we'll add some complicating factors to. Easy to apply, and then that we're saying just, V, if I tell you something has 9 volts, and I tell you its resistance is 9 ohms, then you can obviously do the math right there and figure out that it's just equal to 1 amp. All right, so if we want to complicate it, though, we have to figure out exactly what that means. So we are going to move on towards having different circuits and applying Ohm's law to different circuits. So we're going to have 2 different types of circuits, and so I think, there we go. We can start talking about those right now. So series circuits and parallel circuits. These are names you may have heard before, you may not have. They have 2 main differences and 2 main attributes. It's just about the number of paths. All right, series has 1 path, parallel has more than 1 path. And that's the difference between the 2. Now, if I were to just try to draw a series circuit, it may not be the nicest looking circuit, but it would look something like this. It would be a battery, and then you'd have that battery connected to a light bulb, and that light bulb would be connected to the other side of the battery. And there we have a circuit, and that light bulb would light up, and it would be very exciting. Right, if I were to do the same thing over here with the parallel circuit, it would have to be a little bit more complicated because I have to have more than 1 path. So I have a path to 1 light bulb on one side and a path, and the second path to the other side of the battery through another light bulb. And so we'd have something that looks sort of like this. Well, this brings up some problems, really, because these drawings are terrible. So what we need to do is we need to have some kind of process, and that process is known as schematic diagrams. Schematic diagrams, they're very exciting. I forgot I did this. Big exclamation point, and then yay. Okay, so schematic diagrams are a way for everyone to draw the same thing. So we have these everybody agrees upon type of things, these conventions for how we draw everything. The first and easiest one is a wire. A wire is a straight line, and they meet at 90-degree angles. That's important. Okay, a resistor is a squiggly, zigzaggy line like this. And the longer it is, so the more zigzags, I guess, that it has, the more resistance it has. We won't get into that a whole lot, but it is something that you should know. Then we also have a light bulb. Light bulb, or a lamp, as your reference table calls it, is a couple of loops, 2 or 3 loops, and then a circle around it. This is not an exhaustive list of the stuff that's in your reference table, and you can take a look, but it's enough to get us started here. So this is a battery. The long side is the positive side, and the short side is the negative side. I usually remember that by saying, well, it takes more ink to draw a positive sign and less ink to draw a negative sign. So that's how I remember it's the long side is the positive side. Okay, so we can redraw that circuit from above. There's my battery. All right, I can draw my light bulb, and you see that all these things meet at a 90-degree angle. So we're good to go there. Check. All right. If I were to use all the correct schematic symbols, but I didn't have my wire drawn correctly, meaning it doesn't meet in a right angle, that's wrong, right? So that navy blue one gets credit, and that purple one does not get credit. It's important that we understand these differences here. So we are going to move into working on these diagrams in the near future, and I hope this was at least somewhat informative. Why don't you go ahead and try the problems I posted. Thanks.